How familiar is ReScript to TypeScript developers? Probably more familiar than you think. In this video, I go through a solution for a complex form written in ReScript. I compare it to the solution in TypeScript and invite you to make your own conclusions on whether ReScript seems familiar to you. All right, so let's give some context here. We're working with a form, and it is a tattoo intake form that I was in the process of developing for a client. It just basically presents the user with a set of options about concerning which part of their body that they need to be tattooed. So you can imagine that that list would be overwhelming if all the options were presented at once, and so we kind of guide the user through it through a set of select options that give fewer options at each step, but still get to that precise part of their body that they wish to tattoo. So for example, if I select my leg, we'll present another select option, and I get to choose which leg, and then I get to choose which part of my left leg. And then I can choose another part of the body, like say the hand, and then we'll choose the right hand and the ring finger, right? So that's the essence of the example that we're working through. It's sufficiently complex, and underlying it is a sufficiently complex algebraic data structure that, anyway, it's a great example to go through and compare solutions. All right, so in a previous video, I made this solution in PureScript and then compared it to the TypeScript solution. And in this video, we've made the solution in ReScript, and so I'd like to go over how the core parts of it in ReScript are done, and then just compare the syntax between ReScript and TypeScript, so that we can just get a feel for what it would be like to code in ReScript if you're already a TypeScript developer or JavaScript developer. So let's first take a look at the structure that we're dealing with. It's a tree, and it's a tree of something, and it's a recursive definition. So either we have a leaf of something, or we have a branch of something, and then a corresponding array of subtrees. So it's recursive. And in the case of this application, it's a tree of what I'm calling select input nodes, which is just a set of these properties here. Label, a little validation function, and a set of options for that level. And of course, this is a branch, so this array would represent the set of subtrees, and so it's only a few levels deep. But anyway, you can imagine how it goes from here. But eventually, we arrive at a leaf node, and which has no children or no subtrees. So that's how that works. The core, the component here is, it's interesting and it would be worth going through, but it's really just the core component that I want to keep track, or the core function, which is in the selectTree.res, is gather input nodes. And what this does is it returns an array of nodes that represent the path down that tree and what the properties are to render. So if you're at the root, then you render the root node, and then if you make a selection, you kind of pick a subtree, and then you render that one, so on. So that's what this does. It gathers the set of properties for the components dependent upon your current selection, which is just an array of strings. So let's compare the solutions. Let's go to TypeScript first, the TypeScript solution. So here we have the same type of function. Perhaps let's go through the structures first. So we have a very similar structure. We have an radio input node. We have a tree of something, also a variant. And we have a whole tree structure defined. It's exactly the same. And then we have this core function. So I commented on this previously, but There are some flaws with regards to in TypeScript with regards to how this could be made. There's various traps that you could fall into. One would be forgetting about this special keyword when it comes to exhaustive checking. Like it's very possible that this could have been omitted and developed like this, and it would still compile. So by the way, you can run these, so I'll run them, and you get. I've taken a look at these outputs, and they are correct. They're getting the right, depending on your set of selections, it's getting the right collection of nodes. So you could have easily developed it like that, and then you might have, like, at some point. So without this never keyword, basically you don't get the true exhaustive checking. So you need strict mode enable, and then you need to use this never keyword. And in my case, there's just two options. There's a leaf and a branch. So I could have just developed the branch case and then said, well, what other case is there? Let's put the leaf case as the default case. And then you would run into this problem where, not that you would do this, but like, let's say you added another kind, a twig. And I don't know what that is. Like maybe it contains some other value that we just, haven't thought of yet. It's possible to have added another type, essentially, another variant where then you'd break this exhaustive checking, right? Because you haven't remembered to use the never keyword. There's also some problems with, the head being undefined or falsy. Like, for example, what if the selection was instead of strings, it was actually like Boolean values, right? And you had coded this to be like falsy. Very possible that could have been done, right? And so maybe at the head of your selection is a falsy value, a 0 or an empty string or an actual false value. Like this would have introduced a bug, right? The other thing is that it's totally possible to just have coded the happy path by forgetting that index could be -1. And so I could have omitted that. That's a problem. And what else? That's about it. There's 3 things. And here we have, all right. So there's 3 or 4 things. Exhaustiveness checking. There's just some issues with falsy values on the selection, as well as getting the head of the selection then being a falsy value. It really depends on your skill to have programmed that correctly. And then you have your find index search, which could have returned -1. You could have forgotten to code that case, and you would have gotten a bug in your function. So let's take a look at the solution now in ReScript, and we'll just see that it's a little bit safer, right? It doesn't really look all that different. We've got, first of all, we've got true exhaustiveness checking in ReScript. So you have to specify the leaf and the branch case. It'll give you a compiler error otherwise. All right, so it's there's true exhaustiveness checking in ReScript, so it's not possible to get away with only coding for some of these cases. You have to... Actually, let me open the terminal and just to show you. Okay, it's still running. Amazing. So let me just comment out this leaf node. So it's going to give me gives me a warning, which is interesting because in my opinion that should be an error, but maybe that's configurable. But it does tell you haven't coded for all the cases. Let's move that back down. Oops. All right. What else? So I do an explicit check for size, and then I do a get that throws an exception. So I'm using the part of their core utilities is the belt utility, and so that's what I'm opening here and accessing the belt utilities for array. And so I'm because I happen to know that the size is 0, which is a terminal case, or selection. The selection size is 0, which is a terminal case. Then I can kind of get the 0th element in a way that would throw exceptions. What other options are there in, let's take a look at ReScript Lang, and we'll take a look at the belt utility, API, belt, and array. So get exen, raise an exception if I is out of range, otherwise it return that value. And this one, so I could have also used the get belt utility, which would have returned an option, right? So then I would have had coded like set up another switch case. I chose an unsafe method of getting it because I wanted to avoid a switch case, which in this case I knew would be as already coded for. Anyway, what else? So here's another. So in ReScript, when we do the get index by, it also returns an option in JavaScript or TypeScript because it's a strict superset, and returns -1. You can forget. We just went over that. You can forget to code for that case. In this, you cannot forget to code for that case. You get an option. It's either you found it, it's none, or you haven't found it, so that's none, or you found the index and some index I. Right. So then we do another. Here's an example of using get versus get exception. So based on the index of our selection, then we look for the appropriate subtree of that branch, and that is an option as well. So it's very, very safe. We'd have no subtree or we have some subtree. So what's interesting to me is, so I'm not a ReScript expert. But I find that having watched a few tutorial videos and just glanced at the docs, the learning curve is much, much more shallow. Like if you're familiar with TypeScript at all, or just JavaScript even, let's say you don't know TypeScript, I would say that this looks halfway familiar, and it's actually quite familiar. And I think it actually is a really great candidate for a next generation web dev language because it's in the lineage of, JavaScript and TypeScript. It seems like the next iteration that is just a little bit better, but still has a lot of familiarity. One of the drawbacks I find though is that I'm using I'm using React under the hood. So ReScript has React bindings, so I'm making essentially a React app, which I'm not crazy about. I wish there was perhaps another, like a standalone framework for ReScript, but a lot of development is done in React these days. So I think maybe there will be a framework that comes, and maybe that's something I develop at some point. Who knows? But I do think that this is a really it's very, very close in syntax and look and feel. And just based on my experience of having such a shallow learning curve, it tells me that I'm already halfway familiar with ReScript. Anyway, so I hope you kind of get a feel for ReScript through this video, and I hope you can see that in this example, it's like TypeScript. It's just the next iteration. It's just better, right? It's not a strict superset. You can't make it a drop-in replacement, but it seems like the next iteration of web development, and it's just safer. It has true exhaustiveness checking, and it has a very, very strong type system, as well as it encourages you to use this belt utility, which is a pure functional utility. Pure functional library for navigating algebraic data structures. And I think with that pure functional paradigm seeping in here, it tells you that that JavaScript and TypeScript are going in a certain direction, right? TypeScript is an expression of the desire for more safety within applications at compile time. And we've seen in libraries like Lodash and Underscore that the functional component has been creeping into the language. So it's nice to see that this next iteration, what I think is probably the next iteration of web development, has a pure functional component, which is the belt utility, and it has improvements on the type system that that TypeScript has added to JavaScript. So I hope you've gotten a sense of that in this video, and if you want to see more of exploration of next-gen web dev languages, then like, subscribe, follow me on the journey, and be sure to take a look at the description of the video and find the my email list and subscribe. Folks will get notifications, and you can certainly get access to me personally through the email that's through the emails that I send out. So anyway, thanks again, folks. Bye now.